Welcome back to my YouTube channel. Right now I want you to show another problem from IMC. This time 2021 is a matrix problem which combine the idea of matrix and permutation. So what the problem tells us, consider it like two important group, is like general linear group over ZP and SP, which is like the group of permutation of order P. And what the problem asks us, it's like to show that there not exists, so it's not exist a morphism between GL2 ZP to SP, where this morphism to be injective. Yeah, so we have to show that it doesn't exist, this type of morphism, which is injective. So this is the problem from 2021, problem 6, P6. P6, IMC 2021. So, like in many problem and basic ideas, is to assume the contrary. So I will assume that there exists, so I will assume that there exists a function, a morphism, injective morphism, from general linear group to SP. In this type of problem, the very important thing is to try and to find elements with good order. So this is the case here. Of course, we can try to use like Cauchy theorem from groups or Lagrange theorem, but we can try to catch some good matrices, and here is some examples. So first of all, I will try with minus E2, which is a matrix of order 2. So order of minus E2 is 2, and this one is harder. I will take matrices 1, 1, 0, 1, and when you look at the power of this matrix, I will have like 1k, 0k, 1, and this tell me that order of A is like an informal way of noting order. In a good way is like ORD. So order of A is P. But right now, because this is injective function, I know that this function, it will send this matrix in a permutation, let's call it tau, of order 2 also, so order of tau. This is the main thing that I note here, order, because I want to have a little differences in between GL2 and SP. So here is order 2, and for A, it will send to a permutation which I will note like sigma, and order of sigma is like P. And what we have to constate here is that when we take it, when we consider it like this function of minus A, it will send to a matrix with a permutation, let's call it alpha, alpha of order, the product of these two, these two orders, so it's going to be 2p. But let's look carefully here. Alpha is a permutation from SP, where P is prime. Don't forget this stuff, this important stuff. So here, P is prime number. Prime number. So, what we have here? So we have a permutation from SP of order 2p in the general symmetric group of order P, where P is a prime number. Well, it doesn't exist such a permutation, because when you use the theory which tells us that alpha is like a product of disjoint cycle, this disjoint cycle, let's call it the length of this cycle, let's say L1, L2, Lk. You have, like the order is L1, L2, Lk. Order of alpha. I don't have enough space here. Let's make an adjustment. So this is the order of alpha. But look, this Le is like less than P. So I think we can discuss two cases. Case 1, K is 1 and Lk is P, which is not good, is false. And also case 2, where K is bigger or equal with 2, well, in this case Le is less than P minus 1. So order of alpha is of course different from 2P. So that thing said, I arrive at the contradiction. So it doesn't exist this type of morphism, injective morphism from general linear to SP. And I want to prove a point here. This problem and also the previous problem, integral problems, they look scary, they look hard the first moment, but when you look carefully and when you try and you figure out a way to attack it, things are much easier than it looks at first. So, a general advice, not only in math, but in life, when you see a complicated thing, try to break it in smaller pieces and try to solve each one at a time. Yeah, I think that is the most important thing in life. Well, see you next time. Bye bye.